All right, so read through this. A little statement. This is not a suggestion on an experiment that you should try to run. This is an interesting thing. Some of us might have lived this experience before. I don't know. I have. It wasn't beer, but it was. So if you went out drinking the night before, so a whole class goes out because they'll have Jeff, and they're like, "We need drink." And you go out before. And I am actually teaching a 7 a.m. stats class. It's just isn't you guys. We could survey them the night before to see how many drinks they had, and then see the next day what grade they made on their test. So, you guys get the basic premise. So they go out late, they're drinking beers. Some people drink a lot, some people don't drink much. And then we see how their grades come out. Which one of these is a stronger relationship? Second one, because they're more lockstep. It's more defined. As they drink more beers, what seemed to happen? Grades went down, right? So we call that a negative correlation. Kind of makes sense. It's got a negative slope. I like it. Which one's more realistic? Are the beers going to be totally what determines your grade? Who is this person? Do they drink a lot? No, but how they do? Poorly, because I don't care if you're as sober as hell, it's not going to make up for not knowing shit, right? So this is the person that didn't really drink much, but they probably didn't really study much either. And then who's this person? They drank a decent amount, like they tied for the most drank. I didn't put a scale there, so you can put your own scale there. But they still did pretty well. You guys see this. You guys see it. Does this one also have a negative correlation? Is it like if you had to say the general trend seems to be what for this one? It's clearer in that one, but there is a general negative trend. What are the two outliers, the ones that I just pointed out? If I took those away, the trend becomes a lot stronger, right? You guys see that? You guys see that? Okay. There's a lot of little ideas that go into this that together make sense. I know you guys have some feeling of a correlation. You've seen some version of it at some point. Let's see. So we already said this one, it looks stronger. This one is more realistic though, right? So what we want to do, we want to get to a point where I can calculate a number that tells me how strong the relationship is. And really, what does that really mean? Why is this one stronger? This one's linear also, right? Just what's true about the points though?
Clustered in a certain way. Is that they're clustered in a certain way?
True. So this one is stronger because the points are closer to the line. Could you draw on this one a guess for like the trend? Have you guys ever seen, I know we live in California, I'm aware of this, but have you ever seen the hurricane maps? Maybe you have family, I got family in Virginia, so I'm always looking to see where hurricane's gonna go. Have you seen the hurricane maps? Have you ever seen a hurricane map?
Yes.
Yes? So they look very roughly like, you got a little hurricane dude, right? And here's Florida. Holy shit. Florida's gone through some stuff. I talk about Florida because it's normally the one, you put Lake Okeechobee in there. Aren't you? And what it does is it tells you sort of what the expected track is. Yes? Some of you guys have seen this before. And then right down the middle, you can actually turn this feature off, but they put this, the average. And I love these pictures because they are kind of like average and standard deviation visualized. So of course, the further you try to predict, the worse the variation gets. This is a beautiful example of, it's based on the stuff we've done, but I think you understand it's a lot more complicated, but it still can be interpreted the same way. There's a lot more variables that go into what the hell a hurricane's going to do. Ever. So on this one's easy. Can you draw the line that best fits this data? It basically makes its own line almost, right? Are all the points going to be on that line? If you drew a straight line, could you get all the points on the line? No. If so, man, your straight lines need some work. Even more than mine. Mine don't. Yeah. Yes?
For like the line, would it just be connecting the first and last?
Nope, not necessarily. So we're actually going to do something probably next week. We're going to create our own line and such. Yeah, it's going to be awesome. But if I did have to draw this in, I could draw in a line. Let me go over there and do it for real. There we go, Jeff. So for example, I could say, here's my guesstimate. That's bad. Why is that a bad guesstimate?
It's not
Huh?
It's not like
It's not in the middle. There's more points
down.
below it. You guys, so just looking at it, could you tell this was a bad guess at an average line through that data? Because of those things you just said, right? So when we do this, I didn't necessarily do that on purpose, but I knew it would probably happen if I just went like that. When you try to draw a line that best fits the data, you're going to have to do it a couple times. Because your first time you're going to go, oh shit, it should really be, okay, erase that one, do it again. All right, maybe. How about this guy? If you sort of ignore the two outliers for a second, because they sort of cancel each other out. Can you draw a line that best fits that data? Let me try to be more careful about it. So I'd say something like that. Even that should be a little bit more up. See, that's why I don't care how good you are with statistics, if you're going to do this by hand, you probably have to do it at least twice. Do you guys see that? Does everybody see how that line should probably be up a little bit? Okay. Yes? Are you good? You're stretching. And then I just gave you one more example so we don't have to just talk about beer. And also, this, of course, what did I say? This is a negative relationship. Hours studied versus grade is obviously a positive relationship. So the number that I calculate to tell me how strong the relationship is should come out negative or positive based on which way, right? And again, same idea. Which one of these is a stronger relationship? This one. Which one is more realistic? That one. Who's this person? Person you love to hate? How much did they study? Not much. They barely cracked a book, but kicked ass. So either they already took the class twice, right? Or they just are one of those people, right? Maybe some of you were that people, or maybe you've known those people that don't even have to look at the book and they just kick ass on the test. And if you were that person, I know there's a class you hit that you're like, I can't do that shit anymore. Oh shit, I know I did that for sure. And then who's this person? Studied a lot, but oh shit. All right. Well, this happens. We know it happens. And normally it's because what they think this isn't what they should be doing. Students have their own idea of what studying means. And the more I talk to people about how they study, the more I realize you don't know how to study correctly. So yeah, I studied a lot, but did you do it correctly? I don't know. So this one would be easier to draw a line to fit it, and that one, of course, if I take the outliers out, because again, do you guys see what I mean by they kind of cancel each other out? Then I can kind of see where the line would go. Okay, maybe. Yes?
How do you, what helps you determine, what's more realistic in a situation?
Oh, in a natural situation, I would expect there to be more variation. I would not expect that the hours people study to so directly affect their grade like this. Right? And I know we harp on it a lot, you got to study to do better, but is that the only, here's a key thing, I'm glad you said this. Everything we've done so far is comparing how many variables. How many variables are on this? Not how many values, variables. Yeah, hours studied, grades. And what was the first one about? Beers drank. grades, right? Wouldn't both of those affect your grade? What else could affect your grade? Sleep. That's the first thing I thought of, right?
Stress.
Stress levels. Just bad hair day.
Motivation. Maybe.
Huh?
Motivation.
Motivation. I mean, so this test is, again, everything we do in this class is kind of like a first step, because this is Stats 1. It does a broad overview of things. This test is really good, but it only compares two possible variables. And what affects almost anything is more than just two variables. Okay, maybe.
What do you mean by variation?
About what, sorry?
Variation.
Variation, okay. So when we first studied standard deviation, what did we call it before we took a square root? Variance, right? And the word variation is just how much things vary. Do I expect a lot of variation in ages if I just take a group of students from this college? Would I expect a lot of variation in their ages? Yes.
Is variance coming back this chapter?
Say again?
Is that coming back this chapter, variance?
Yes, this is basically like a two-dimensional standard deviation. How spread out from the average line are we? All right. So these numbers we're going to calculate. One of them is given the symbol R. So this is why I try to get you guys to draw a sigma instead of just an R for standard deviation. Because there is an R, and it stands for the Pearson product or the correlation coefficient. Of course, my stats teacher was Mr. Pearson. I remember him. And he didn't try to take any credit for that, but still, it's kind of nifty. It wasn't the real Pearson. That was from forever ago. He would have been like 213. Blah, 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 blah. So listen. There are two things I want to calculate from a situation like this. I want to calculate the number that tells me how strong that relationship is. And I also want to calculate the line that best fits that data. So let me say that again. Best fit. The line of best fit. That is the real name of this thing. Because it's what the shit it does. So I got a bunch of points. Is there a line that best fits it? Yes, there is. Now when I draw it, the one I just drew is not the right answer because I'm a human. Holy crap, I can just do the best I can. We are going to do, this is the one chapter where I do most of the actual calculations using the calculator directly. And you know my mantra about that, right? But let me just show you. Oh shit, did I even bring it? I would have shown you. Yeah, I decided, I'm going to class. I don't need my book. Anyway, so I was going to show up there for you a little horror show about what the formula for R looks like. It's really just yummy. It's just huge. I know if I say it's yummy, then you know it's gross. Right? So but it's mathematical. So here's the idea with this number, this value for R. If I get a -1 for it, it means perfect negative correlation. Now, for example, is this perfect negative correlation here? What does your gut tell you? Is that perfect negative correlation? What should perfect mean?
Like on a straight line.
That is a straight line. I drew a straight line.
Oh.
But what's wrong with it? Why isn't it perfect?
Not all the time.
Because the dots are not all on that line. So if I had a situation where the dots perfectly lined up in a negative fashion, that would be perfect negative correlation. That would have a value of -1. And why does it make sense? Because what should no correlation have a value of? 0. So -1 means perfect negative. 0 means no freaking correlation. And +1 means perfect positive correlation. So if I had a bunch of points that were lined up perfectly on the line and I started to pull them away from the line, my R value would get closer to 0. Let me try to say that again. if I had a bunch of points that were perfectly lined up like that, so that's perfect negative correlation. Let me make that one bigger. And I just started pulling. I like pulled this guy over here and I pulled this guy over there. So now it looks more like, it's still negative correlation, right? Well, it's really hard to tell with just 4 points, but let me put some more points. Bam, 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 bam. So that's still negative correlation, correct? But it's not perfect anymore.
So like when it becomes more like realistic.
When it becomes more spread out, away from the line, my R gets closer to 0. If I just had dots that were just all over the place, so like this, just measles on the paper, that would be R equals 0 or close to it. There is no line that captures what that data is doing. Do you guys see that? -1 means they are perfectly negatively correlated. +1, perfectly positively correlated. So as one gets bigger, so does the other one, exactly lockstep. That would be no linear correlation. They just don't interact.
So it'll only range between -1 and 1.
Beautiful.
You always use that word, like perfectly negative.
Yes, totally. R equals -1 or 1 is perfect
Whereas like
negative or positive correlation.
1.02.
Can't be greater than 1.
Oh.
Because 1 is perfect, right? It's not like perfect cell and then it becomes a little more perfect. Golden.
If it's like an in-between value though, then that wouldn't be perfect. Right?
Exactly. But if I said I had R equal to 0.98, it's trying to be just an R. Would you say that's strong positive correlation?
Yeah.
It's almost freaking perfect, right? It's almost 1. So I'd say that's strong positive correlation. So, for example, the amount of increase in a paycheck for a teacher and the sales of liquor are positively correlated. But here's a perfect example about, is it because teachers drink a lot? Well, yeah, but not just because of that. Because if teachers' pay went up, more than likely a lot of other people's pay went up. And then I bet you that everything you could buy kind of had an uptick, especially luxury items. All of a sudden you got a little more money, guess what? I'm going to get some better booze, right? Unless you don't drink, and then you're going to get, I don't know, whatever you want to get. Yes, no, maybe so? How about this one? Here's one that's a misinterpretation. Somebody goes and watches a bunch of basketball games, and then they write down, basketball makes you taller. Interesting. Let me say that again. They go watch a lot of basketball games, and they write down, from observing the people playing, they're like, basketball seems to make someone taller. Is that true?
No.
I love you guys. What's true? What's the reality?
Tall people play basketball.
Yeah, tall people are more likely to play basketball, right? Now, does that mean that no short people play basketball? No. There's this 5'2" dude I read about in the paper. I can't remember what he plays. It reminds me of Muggsy Bogues, forever ago, spud away. Anyway, so there, all the damn time, you hear these in the news, where these two things are correlated. If this goes up, this goes up. But they're implying that there's a causal relationship. I don't know if one thing causes the other thing to happen. In the example about playing basketball, we already know the reality, so I can interpret it correctly. But when we have a brand new situation and people see a relationship, we don't know what causes what, or even if there's a third thing causing both of them, we don't know. So correlation does not mean that something affects something else. So on these two examples I gave you, does this mean that if you started studying more, your grade would definitely go up? Is that what this study means?
Yes.
Yeah.
No. Nope.
It's more likely.
So tell me, each of these dots, are they all one person?
No.
Each of these dots are different people, correct?
Mhm.
So this is a snapshot of different people and what they look like. How many did they study? How many hours did they study? And what's their grade? This is not a test that can tell you if you got more hours of studying, would your grade go up? This test cannot tell you that. It just says there's a relationship between these two things that I see. Could you create a study that would see if you study more, you get a higher grade? Of course you could, right? Sort of related to testing if a new drug works or not, right? Yes?
Would it be wrong to use like the term more likely? Like if you
Yes.
put more hours of studying, you're more likely to get a better
Not from this study. We can't say that. We can say there seems to be a relationship between studying more and higher grades. So let me ask you this. Students who get higher grades, could they just be better students in general? So here's a weird thing for you. Getting higher grades could actually mean that makes you study more. Who goes to the tutoring center? No. I mean, what kind of students go to the tutoring center? Normally, what kind of students go to the tutoring center more often are good students, A students. Why do they do that? Because they know what it takes to get an A, because they got a freaking A. I'm not saying only grades A students go there. That's never what I'm saying. That's the beautiful thing about stats is I ain't never saying all, right? It just is more likely. Okay. So, if I do a correlation study, I'm taking a snapshot of, does it look like these things are related to each other? How you interpret that correctly is up to you, right? It is still good to see if there's a relationship. What could I do if I saw this? What could I then do to really study it further? I can set up a where I can have a group that I don't let study and another group that I'll let study. You have ethical considerations that you got to take into account, but I could set up a study to see, does it really seem to affect it? This doesn't tell you about the effect. It just tells you about, are they related right now? Let's see. So there's the thing about R. It's between -1 and 1. That's the strength, but we also want to figure out the line of best fit. And you have to remember a little bit about lines. Who can tell me one equation of a line? Y equals mx plus b. I like it. What's another equation of a line? I'll do this. Y minus y1. Does anybody remember this one?
No.
Y minus y1 equals m times x minus x1. Has nobody ever seen that? Some of you guys maybe? Okay, a few of you guys are saying yes, so I feel a little better. I love you guys. So what is it about mx plus b? Can somebody tell me anything about this m and this b weirdness? BMX, is that what it is?
Slope in the y.
Slope, right? Y-intercept. I love it. So you can only really use this equation if you know the y-intercept. If you don't know the y-intercept, you just know some general points, I can use this one. This one, because math people are really creative, is called point slope form. Because you got a point, you're sloping. This one's called slope intercept form. There you go. I like it. Okay. So hopefully that feels a little bit familiar. I want to do one more thing with you today, I think, and let us out a little early. If you look on the back, I've given you an excerpt from the calculator guide that I have up on the website. If you have never looked at the calculator guide that's up on the website, I don't really understand you too well. You probably should go up there. It's up to you, though. You don't have to.
Is there stuff in there that you don't use, or you?
What do you mean? Like what?
Like binom, that you have.
But it's good. I'm just putting it there so you know, so you can check yourself. Check yourself. This one is the one I will definitely use for damn sure. So I want to go through one example of this. And the first step is something you guys are very familiar with. Can we go ahead and do this one? Go ahead and put this stuff in L1, the number of beers somebody drank, and put these in L2. If you need to borrow a calculator, coming up here. I'm going to do this with you guys.
Yes, right.
Do you guys think I should ever sort these?
What?
Should I sort these lists?
No.
Shit, no, because they got to go together, right? That specific X and that specific Y have to stay together.
68. 86.
Oh, so evil. Right. Okay, let's get. Okay, that helped me. Yay. So what I always do when I got all these things to put in there, I kind of stop halfway down the list to make sure it's going with the right X value. Do you guys see what I'm saying? Because it really sucks when you do this whole thing and the lists aren't the same size. That sucks. All right. So let me ask you this. Well, let me tell you this. This whole first row are graphing utilities, right? And that's exactly what we want to do. We just put in, effectively, we put a bunch of X's and Y's in here. And I want to plot them. And these are statistics, right? These are things that I've gathered. So look right above Y equals, what's it say? Stat plot. So I want to go there. So the first thing we're going to do is just recreate the scatter plot. That's what this thing is called. This thing right here is called a scatter plot. Isn't that a perfect name for it? Reminds me of like scatter shot. Looks like buckshot on something. So if I hit stat, let me go backwards. I'm not going to do that yet. If I hit second Y equals to go to stat plot, that's where I want to be. Let's everybody do this. Everybody hit 4 to turn all the plots off, 4, enter. We do it again. So in here you just hit number 4, enter. Just to make sure nobody's got extra plots on and it gets all freaky. Everybody with me? All right, go back in, second stat plot, and let's go into the first plot. And here's where we can start to say, man, maybe I should get a manual for this thing because look at all the stuff, histograms and box and whisker. Oh. The one I want is the first one. That's the scatter plot. Is everybody in this list right now? Everybody here with me? No?
Yeah.
Let me go back out. Got it. Let me know the minute I pull ahead of you guys. So stat plot. Go into the first one. Hit enter to turn it on. Make sure that one is highlighted. Now everybody's with me now, right? No? Let me try again. Second Y equals. Hit enter for plot 1. And now hit enter to turn that bad boy on. I want to pick the one that's a scatter plot. So make sure you hit enter on top of this guy. My X's are in L1, my Y's are in L2. Is everybody still with me? And then you get to pick what point, what symbol to put on every point. So I, of course, pick a square. So I'm a math teacher. You could be positive, you could be a big speck, or you could be a small speck in the universe. Whatever you want to use. So that's just going to put that symbol on top of every data point. And then me, I can pick what color I want. So if you have one of the older ones, you can't. I don't know, what do I want? Holy shit, there's a lot. Green. You could do magenta. Now watch. Now if I hit graph right now, I'm going to get something really unsatisfactory. What? Jeff, thanks man. You have led us astray. You assholes. So what you got to do is you got to tell the calculator, I don't know if you've ever used these calculators before, but when you hit the graph button, it shows you whatever it's been told to show you. So whatever it's been set up to look at. So what I got to do is this. Go to Zoom. I'm gonna clean my poor cover. And then which one looks like it's the one I want to use? Probably the one that's got the word stat. So if I zoom stat, it's going to zoom in on my statistics. It's going to zoom in on my data points. So everybody should get that. Okay. Yes?
How do you get to the actual graph?
All I did was I hit zoom number 9.
No, like before that, when it was just empty.
Oh, I just hit the graph button. All right, let me know. Anybody else? What's up? Yeah. Okay, I love it. Yours is going to look different because your window is set up differently. Everybody's could look different.
And then
But
Zoom.
Zoom 9. Zoom. Yeah, I know. Zoom. You got everything set up. Let's make a stack. All right. Then graph it, and then zoom, zoom, zoom button. Zoom stack. All right, how's everybody? Everybody got that showing up? Give me their green measles. Okay. So if you look, I tried to make it somewhat like this. You did okay. All right. So, last thing we'll do. Oh, we gotta get out really early. You guys all right with that?
Yeah.
You sure? All right. Last thing we're gonna do is calculate the R and the line of best fit, and then get the line of best fit to show up on the screen.